November 2019, paper 1, grade 10, pure maths. Question number 2. 2.1 says solve for x. So 2.1.1 is 2x squared minus 10x is equal to 0. When we solve for x, we want to take out the most common factor. So I'm going to take 2x out because there's factors that can apply to both of them. That leaves me with x minus 5 is equal to 0. So now I can have two statements, this one and that one, and I can say 2x is equal to 0, which means that x is equal to 0 because I divide by 2 on both sides. Or I can say x minus 5 is equal to 0, which means that x is equal to 5 because I add 5 on both sides, right? So those are my answers. X is 0 or x is 5. Question 2.1.2 says px minus kx equals k minus p. So we want to solve for x. You can see p and k, k and p, that repeats, right? So let's see if we can take those out as being common. Or instead of that, let's take x out because we want x alone, right? Let's take x out. Oh yeah. If I take x out, then I'm going to have p minus k is equal to k minus p. Okay. I can rewrite that as saying x is equal to negative k plus p is equal to k minus p, right? And if I want to change the sign so that they're exactly the same, I take the minus out. So I'm going to change these two signs, which means I need to change the sign on the outside, right? Over there, which is plus. So it becomes minus plus minus. That's the intention. Minus x is equal to k minus p, k minus p. All right. So what am I going to do? I'm going to divide both sides by k minus p, which means that x minus x is equal to k minus p over k minus p. And that gives me 1, right? Those two cancel out, become 1. So negative x is equal to 1. Then x is equal to negative 1. The end. Next question. 2.1.3 says 2 with the exponent x over 3 is equal to 1 over 128. All right, we want to get the same base. So we're going to keep that 2. And we're going to say this is 2x over 3 is equal to, let's do the roots, or I'm going to do it manually. 3, 4, 5, 6. 6 is 64, 7 is 128, 7. So this ends up being 1 over 2 to the power of 7, which I can then rewrite as being 2 to the power of negative 7. And this is x over 3. Okay. I'm going to, because I have the same base here, 2 and 2 means my bases can fall away, which means I have an equation that says x over 3 is equal to negative 7. So I multiply by 3 on both sides, which means that x is going to be equal to negative 21. And that's my final answer. All right, so this is question 2.1. Let's go to question 2.2. Okay, so 2.2 says x plus 5 over 2 is greater than negative 2. 2.2.1 says solve for x. We want x alone. So what you need to remember is that that less than and greater than sign stays the same unless you are multiplying or dividing by a negative sign. It changes when you do negatives, right? So I am going to multiply by 2 on both sides, and I'm going to say x plus 5 is greater than negative 4. Now I'm going to subtract 5. Now notice I'm subtracting, I am not multiplying. And since I am subtracting, the sign stays the same. The sign changes if I times or divide by a negative sign, but I am merely subtracting. So I'm going to say x is greater than negative 9. And that's it. If I had to draw this on a number line, I would have negative 9 over there, open circle because it's not included, and greater than negative 9. Question 2.2.2. The question says, if x is an element of all real numbers, represent the solution on a number line. Oh, we did that already. So this is 2.2.2. There we go. On the number line. All right. Let's do 2.3. 2.3 is solve simultaneously for x and for y if you are given this equation. Now, normally when they say simultaneous, they give you 2 equations, 2.3. But in this one, they only give you one. They're saying x minus 3 plus y, 3 minus x is equal to 0. So how are we going to do this? You see similarity here, right? You see x and minus 3, 3 and minus x. So let's change the sign in the second one. Let's change the sign here in order to make this bracket look the same as the first one. We're going to say it's x minus 3, that stays the same. Then minus y minus, sorry, let's do that in yellow, minus 3 plus x equals 0. I'm going to rewrite it. X minus 3, this becomes minus y, x minus 3 equals 0. So now I've achieved what I wanted. I've got 2 identical brackets. Are you in agreement with me? All right, now that I have the 2 brackets in the rectangles that are the same, I can put the outside ones together, and I can make this x minus y in one bracket, and in my second bracket I'm going to make it x minus 3, and they are both equal to 0. Now I've got my 2 options because they're both equal to 0, which means one or both are equal to 0. So I can say that x minus y equals 0, so x equals y, or I can say x minus 3 equals 0, so x equals 3. And if x equals 3 and x equals y, then if I take this way, then y equals 3. Or I can write it the other way around, and I can say, y equals 3, because I have now just specifically said that x is 3. So there you go. So x is 3 and y is 3. Okay, so that is question 2.3. And then we want to do one more on this one, which is going to be question 2.4. They're asking how many notes of 10 Rand, 20 Rand, and 50 Rands were collected. During a fundraiser, only 10, 20, and 50 Rand notes were collected. In the final count, there were twice as many 20s as 50s. There were 15 more 10s than 50s. Okay, so let's write this down. Again, because I have this printed out, I'm going to just work from my notes. Question 2.4 looks like this. We are saying we've got 10 Rands, 20 Rands, and 50 Rand notes. We're going to make 50x because both of the other two are in terms of x. Our 20s are going to be twice as many as the 50, so 2x 10s, 20s, and our 10s are 15x for the 10 Rand notes. Okay, so the next statement they're saying if 10,150 was collected in total, determine how many of the following notes were created. Now, if there are 15 10 Rand notes, it means that it's 10 Rand times 15, right? Or, let me read it again. It says 15 more, twice as many, 15 more. Not 15 times, but 15 more. So it should be x plus 15. Plus 15. 15 plus x. And then this one is going to be 20 Rand multiplied by 2x. And this one is going to be 50 Rand multiplied by x. Now, why did we do this step? In order to get the Rand value. And all three of these equations together is equal to 10,150 Rand. So if I write this out as an equation, I am going to say 10, 15 plus x plus 20 2x plus 50 times x equals 10,150. Now I'm going to do FOIL, and I'm going to say 150 plus 10x plus 40x plus 50x is equal to 10,150. Now I'm going to add like terms, which is all my x's here. And I'm going to say 150 equals 10,150. And that is 50 plus 50 is 100x plus 150 minus 150 minus 150. So 100x is equal to 10,000 Rand. Then I divide both sides by 100. So I cancel 2 zeros and I cancel 2 zeros. So x is equal to 100. Now, if I go back to my table, I am now able to say that I have got 100 50 Rand notes, 100 times 50 Rand notes. I have got 2 times 100, which is 200 20 Rand notes, and I have got 115 10 Rand notes, and that should give me my total. We can put that into the calculator. 115 times 10 plus 200 times 20 plus 100 times 50 gives me 10,150. So there you go. That is the end of question number 2. Thank you for watching. See you for question number 3. Please like and subscribe. Bye-bye.